Hey everyone, my name is Kyle Shevlin and welcome to my talk called Use Encapsulation. I believe my subtitle, at least in the programming, was Using React Hooks Sensibly. And then as I worked on it, I also came up with ones like Making Hooks Make Sense, or Making Sense of Hooks, or Hooks Make Sense of You. I don't know. I couldn't really decide on one, and so you can have all three. I want to give you a preface before we really dive into the meat of the talk. I struggled and agonized for hours, days, weeks, months, as some of you might know if you follow me on Twitter, on coming up with the format and structure of this talk. And I decided rather than worry about getting it right in one take, that I would do something in nearly the complete opposite sentiments of a famous Bill O'Reilly meme. Tangent. I hope everything I believe is an absolute opposite of Bill O'Reilly, but I'm going to fix it in post. So what you might see transpire over the next 20 or so minutes is a combination of me talking by myself in my office to you. You might see my outfit change. You might see the lighting change a little bit. But hopefully it gets all stitched together into one good and useful talk about encapsulation and React hooks. Now, if you're here to listen to my talk, I'm going to make some assumptions that you know React, or at least are interested in React as a framework for building out complicated and complex front-end UIs. That said, I truly do believe the things that I'm going to teach you here go beyond React. They might even go beyond JavaScript itself. They're really fundamental concepts on how we make code in a understandable and organized fashion. And I hope you'll agree with me by the time we're done. Hey there. Now, the too long didn't watch of this talk is really quite simple. Take the related pieces of code, encapsulate them and wrap them in a function, give it a good name, and call it. That's it. I don't understand why people are so afraid of functions. I don't understand why people just want to write line after line after line of imperative code throughout their entire component body rather than wrap it together in a function and call it. I don't get it. Like, why are people afraid of functions? I mean, good golly, it's the first thing you learn when you code. Sorry about that guy. He's just really passionate. Why don't we get into what the problem is? The problem is the same problem we have with all code. That code changes, requirements change, and thus we need to make updates to that code. If code never changed, if requirements never changed, you could write it once and it wouldn't really matter what way you did it, assuming some level of performance is achieved and your customers or your users are happy. But that's not really the reality, right? Code changes frequently, and therefore we have an incentive to try and write code in a way that makes it easier to change. And part of making that easier to change is making it easier to understand. The truth is, we spend so much more time reading code than writing code. And yet, we actually don't take a lot of care about how we write code so that someone in the future can read it. Now, there are some main things that I've seen in my career as an employee working on React apps and as a consultant working on React apps. And that is, I see a lot of ad hoc React hooks used in components. I see an aversion to using custom hooks. I see logic strewn about throughout the body of our components. I see that logic isn't gathered or correlated in a understandable way. You end up seeing callbacks thrown everywhere, effects thrown everywhere, and very little organization is actually considered. And I think we can make vast improvements to that with just some small techniques. But before I show you those techniques, before we get into the solution, why don't we spend some time making a timely, culturally relevant, contrived example? Now, you can see up here I have some code and I have a browser. Currently, I'm returning nothing. Your project manager comes up to you and says, hey, you, I need you to make me something where a user can input some HTML and you display that HTML somewhere else. We're going to call it an HTML encoder. And just like this, you make the HTML encoder. Now let me walk you through this since I didn't want to bother you with all that typing involved. We've added a text area that's controlled by some useState. Something, if you write React, you're very familiar with. We have the state value, the setter for it. If you follow my writing, you know that I prefer declarative state setters. And so I've written a few of those. We have handle change, which is used on the input, and reset value, which we can use with our reset button over here. And then we'll walk you through some of the markup. You have the title. I have a text area component. I have some of these layout components, spacer and flex. They're not really important. Just don't want you to get too distracted by them. And then we have our buttons. And then down here, I have a special component called hack display. And you'll know why we're calling it hack in a little bit. And there you have it. We have our HTML shown on the screen just like our project manager asked us to. But code changes. It always changes. So our project manager comes up to us and they're like, that's really great, but we don't want to display the HTML right away. We want to hide it. It's a bit of a secret, you know? It needs to be revealed in a way. Can you add a button that will hide it and then reveal it? And you're like, sure, can do, just like this. There you have it. We now have our hidden hack display. We've gone into the code, we've ad hoc'd it, we willy-nilly'd it, we added an isOpen, and we added some declarative handlers for that. And then we realized we needed to add some of those handlers into our other handlers. We've updated those dependencies. And as we look through the code, we could see we added a couple things. I added a variant to this button. You wouldn't want it to be confused with the reveal hack button. The reveal hack button was added, and we even disable it if there's no value. I'll show you that in a second. And then we've made this bottom part conditionally rendered. And so we come over here and we reveal the hack. We could see our hack the planet marquee. If I hide the hack, it just closes it, doesn't do anything. Reveal it again. But if I call reset, let's look at the code real quick. If I reset the value, we're also going to close it. So reset, and you could see that the button has been disabled. We covered all the things our project manager wanted to, but are you starting to see the same problem I'm seeing? If I get in here and I look at this code, if I were to really squint at it, right? Like not try and look too closely, what you would start to see is separation. That's what I see. We have this state setter here, line 10, but its handlers are interrupted by another state on line 11, who's further interrupted by the handlers because they're all the way down here. And there's some intermingling going on. You can see that this is starting to get just a little confusing. Someone has to actually read closely each callback to understand what it's related to. There's really nothing in the code yet telling me like open is related specifically to isOpen other than the names are similar. There's some confusion a-brewing, and it's coming. And to make it worse, our project manager comes to us once again. The project manager goes, look, this has been great. I need you to do one more thing. I want to add some tension to how fast people are reading this decoded HTML. It's really secret, yo. In order to do that, can you add me like a 5-second countdown that once they open the display, it starts counting down, and when it hits 0, it closes it? And you're like, yeah, I can do that. And then just like this, and there you have it. You can start to see already that there's some changes to the code. We've had to add this const for our initial countdown of 5. I've added some state here to manage that countdown. And then all the way down here, we have some handlers for it. We have a decrementer for it, and we have a resetter for it. And then in order to make our code work, we needed to add some use effects. So now we're getting into new React hook territory, and that can be a little confusing for some people. I'll go through the code really quickly. If they close the display, that is, if open changed, we're going to need to reset the countdown, and we want to return. Otherwise, if it's changed to is open, we need to set up an interval that'll decrement the countdown every second. And when it's done, we want to clear that interval. And then on top of that, we're going to have another effect keeping track of the countdown. So when the countdown gets to 0, we need to close it, we need to reset it, and we need to reset the value. Let's give it a try here. Let's go over to our browser, and we're going to click reveal the hack. And it's there, and it says you have 4, 3, 2, 1, and it's gone forever. Until you write it again, of course. We have managed to cover all these things that our project manager has asked us to do, but in the process, we've created a pretty complicated component. And I'm just not convinced that this is the best that we can do. I think that there's a really simple approach that we can take and solution that we can employ to make this a whole lot better. The solution to the problem is so plain and simple that some of you are going to reject it. You're just not going to believe me. Don't worry about it. It's okay. See, as engineers and developers, we become conditioned to assume that the solution to difficult problems always involves cleverness. And that's just not true. I assure you that what I'm about to teach you works. I've done it hundreds and thousands of times now. What we're going to do to solve our problem of our React hooks growing and becoming harder to understand is we're going to use encapsulation. And because we're talking about React hooks and every React hook has to start with the word use, we're going to use encapsulation. Now, what is encapsulation? Well, literally, in capsule. It means to take our concerns and contain them. This word comes from object-oriented programming, where one object should be the container for a particular domain. But we can apply those same principles to functions as well. In fact, both objects and functions in JavaScript use those curly boys. So try and think of them as the edges of our container. Right now, our code is a lot like the pages of a book without their covers, just strewn about. We have to read each individual page to know what that page is about, and we don't know which pages are necessarily related to each other. So what we're going to do is we're going to take our code and we're going to give these books some covers. In fact, hooks, functions, code is the one place you want to judge a book by its cover. I want to know what it does by its title as quickly as possible, leaving the implementation details somewhere else, only to be examined if I really need to. So we're going to borrow a play from the playbook, literally. The Refactoring Playbook by Martin Fowler. And we're going to start taking our hooks and this logic and we're going to encapsulate them in custom hooks. And I'm going to show you how easy it is. Looking at our contrived example here, we have 3 states and we have a bunch of handlers for them. One of the most common patterns you'll see for custom hooks is a state combined with some handlers. So what we're going to do, we're going to, in the same file, in fact, before I do that, I'm going to fold up the UI because I'm going to have to scroll up and down a lot. I want to prove to you the UI isn't going to change at all. But in the same file, and this is what I would recommend to you too, we're going to make a new custom hook. We're just going to call it useOpen for right now because we don't have a better name and we're not worried about that at the moment. And what you're going to do is I'm just going to gather all those pages, all those pieces about being open, and moving them into here. So I'm going to take that. I can actually delete it now. And I'm going to take these and I'm going to cut them out. And we'll bring them down here. And I'm going to show you a refactor in a refactor. One way to make stable callbacks really easily, rather than using useCallback, is to create a handlers object. I do this all the time, and we use React useMemo to make this happen. I'm going to return an object, and these handlers will be the methods on that object. And then I can get rid of the ones that I had here, and we're going to return a tuple of those state and those handlers. I'm going to hit save. Our browser disappears because it's broken at the moment, but we're going to fix it here very quickly. I'm going to take useOpen, and I'm going to destructure those values again. I'm going to hit save, and you can see that the browser comes back and it's working again. We've already made our code more declarative. I don't have several handlers in here related to this. Everything related to the opening and closing of our component is on one single line. Let's do the next thing with the text area. We'll just call this use input. Now I need to make a quick pause here because this process reveals that we had some somewhat misunderstandings in our original code. I have set value here, and I don't have a specific callback that handles just the value. This is what I meant by hooks being imperative and leading to poorly correlated code. We really need to have an update value handler method and a reset value method, and this should be a handle reset. So I'm going to make those changes really quick. I've put those all in place now. Use input, and we've destructured our value, and we've even been able to rename our handlers to be specific for our component. That's another great tip about destructuring with custom hooks. I'm going to do this one more time really quickly for countdown. I'm going to create a hook that does the state and the handlers. All right, I've done that. I've now taken countdown and put it in a use countdown hook. And here we get to an interesting point when refactoring hooks into custom hooks that I think is really useful. In fact, it's what started this whole thing for me. I'm going to put a tweet on the screen really quick here. This was my first realization when it came to writing custom hooks, is that it was a way to indicate what an effect does. When I look at these use effect hooks, I have to read every line to really understand what it's doing. If I'm nice to my colleagues, maybe I leave a good comment that explains it. But I think really the best way to do it is to wrap what happens in a use effect hook in a custom hook with a good name, and maybe even leave a comment still there. This use effect hook does what? It manages the timer. That's what this one does. So let's write a custom hook that manages the timer. So now I can take this, and because I've used the same names above, I can replace it up here with use manage timer and the dependencies passed in. And our code will still work. We're going to do the same thing here. This effect is something different. This effect manages the display. So we'll call it use manage display. And there you have it. We've been able to make our component. Look at the body of this. It's much smaller. We've reduced a lot of lines. There's much fewer lines that we actually have to read to understand. The only imperative code in here is how do we handle the change and handle the reset actions. Everything else is handled declaratively through our various custom hooks. We've even been able to take our effects and remove some of the confusion over what's going on. Now, all we have to do when we recognize we're having an issue with the timer is we go check the timer. Or if we're having an issue with the display, we check the display. By using encapsulation, we have reduced the surface area that we need to check when we're making updates. Now that we've encapsulated our concerns, we can actually start to see opportunities for reusable hooks. If I come down here to the use open hook, it's very clear to me that what this really is a hook that manages a Boolean, and I will use that over and over in my code. I'm going to rename this to use toggle instead. And we'll just change this to state and all of these to set state. It doesn't really matter what we name this internally because it's going to get renamed externally. And then this will become on, close is off, and then we can add a toggle really easily. And then we have a nice fundamental hook to use throughout our code base. I'll take this and I'll come back up here. I'm going to swap it to use toggle. And then instead of open and close, I have on and off, but with object destructuring, I can rename them very simply. And our code continues to work. If I had the time in this talk, I could extract this to another file. And you'll see this more and more often. Focus on encapsulating a concern and you will find the reusable parts really quickly. Now, what good would it be for me to give you a pattern to follow if I didn't have a way for you to enforce it? Lucky for you, I've written an ESLint plugin that you can install in your code bases now that will force you to use custom hooks. It won't allow you to use the direct React hooks inside of a component without the indirection of a custom hook. I'm going to add that really quickly with a little bit of movie magic. With that installed, it now warns us anytime that we're using a React hook inside of a component without using a custom hook. This is enough of a reminder to you to use custom hooks to your advantage to create declarative code. Custom hooks aren't scary or intimidating. They're just functions. But using functions is a way we encapsulate our concerns and make our code more understandable. And when we make it more encapsulated and understandable, we gain reusability, not the other way around. So I encourage you to go forth in your React projects and don't be afraid to make custom hooks again. If you need help, you can refer to my blog post on the topic. It's called Use Encapsulation. I'll put the link on the screen. And if you need a linter to help you as well, remember the package that I just showed you. You can install in your project. I recommend putting it on a warn at first, and over time, building yourself those custom hooks in a way that improves your code base. I really appreciate you taking the time to listen to my talk. I hope you follow me on Twitter, ask me any questions that you may have there, and have a great rest of your CascadiaJS.
All right, and that was amazing. Thank you, Kyle. You know, before we get into the questions for the Q&A, I want to point out that there's been some lively discussion on your AMA section on the Cascadia Discord. So folks who want to know more can check there for questions, answers, links, and apparently a photo of your cats.
Yeah, got to pay the cat tax.
Got to pay the cat tax. Still, we got a couple of things to ask here. So first off, okay, they bought into the pattern. What are some next steps?
So I think some of the next steps are you'll soon and quickly realize that there are common patterns of combining things like state and handlers, which I make mention of in the talk, but you'll also see things like ref is really a way of managing state, but it's also a way of stabilizing state. And so that will also have updaters. You'll recognize that like use callback and use memo, these are stabilizers. And there's just these four categories. I have them in one of the posts that I have a link to in the AMA section. And once you start to see these patterns, it just becomes so easy to write these hooks. It stops being intimidating. It really becomes kind of enlightening and an eye opener for a lot of people that I teach this topic to.
All right, and are there any times where you might not want to use encapsulation?
You know, everything in coding, and often you got to have that caveat, right? It depends, but I think most of the time, no. I think the only time you might be okay with it is if maybe you're making the design components for a design system, and these are just the leaf nodes in the graph of your app, right? And so there's really nowhere else this logic might be, and it might be okay if it's small. But I would highly encourage people try the ESLint rule out. Just even put it on warn, give it a shot. And I think you'll really enjoy how the pattern organizes your code for you.
All righty. Well, thank you so much, Kyle. And that's going to finish our talks for today. But don't go yet, folks. We've got the Cascadia Cup finale, a closing message from Carter, and then JavaScript trivia. And join us tomorrow when I will open with a clean, retellable dad joke that you'll really enjoy, if you can hear it. So
fingers crossed.
Yeah. Now let's head over to the Cascadia Cup finale.